188 merge sorted array. You are given two integer arrays nums1 and nums2 sorted in non-decreasing order, and two integer m and n representing the number of elements in nums1 and nums2. Merge nums1 and nums2 into a single array sorted in non-decreasing order. And the final sorted array should not be returned by the function, but instead be sorted inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, let's see this example. In this example, this is nums1, this is nums2 that is given to us. And nums1, as you see, it has length of 6 and it has 3 zeros. It's because nums2 has length of 3, and we are going to put this stuff in here and sort it in non-decreasing order, and we don't need to return anything, but this is going to be the answer. But for knowing that how many elements that we have in nums1 are the actual values, not the 0 ones, m is given to us. So after sorting this array, this is what we are going to get: 1, 2, 2, 3, 5, 6. How about this case? In this case, the nums2 is empty, so there is nothing to add. So we are going to just return that as a result. And in this example, we have 1, 0, and the length is 0. So 0 is not included in this array. So if it is 0, it means it's an empty spot, right? It indicates an empty spot. So it has length 1, so we are going to put this in nums1, and that's it. So let's see how we can solve this problem. For solving this problem, what I'm going to do, I'm going to use, let me write it down here. To solve this problem, I'm going to use 3 pointers, right? I'm going to use 3 pointers. One pointer is going to be for nums1. Another pointer is going to be for nums2. And there is another pointer which is going to be for nums1, but this one starts at index m minus 1, which is the length of the actual length of the nums1, and this one is the m plus n, right? And I will go use these pointers. What I'm going to do, I'm going to start from the end of the array. We iterate over, we compare what we are going to do, then we are going to compare the value that we have at pointer 1 with the value that we have at pointer 2. And if the value that we have at pointer 1 is bigger than the value that we have at pointer 2, we are going to put P1. Otherwise, we are going to put P2. So if it is bigger, we are going to put P1. If it is smaller, else we are going to put P2, the value that we have at pointer 2. So let's see how we can code this. So what I'm going to do, I need to get the actual length of the array, because I want to point to the end of each array. So for P1, it is going to be m minus 1, and for P2, the pointer 2 is going to be n minus 1, right? And then what I'm going to do, I'm going to have a for loop, and this for loop is going to be for P in range. And what is the range here? It's going to be m plus n, which is, let me write down an example here. So let's say we have 1, 2, 3, 0, 0, 0, and we have nums2, which is going to be 2, 5, 6. So we are going to have the pointer 1 here, not here. We are going to have the pointer 1 pointing at 3, and we are going to have the pointer 2 pointing at 6. We also have another pointer, pointer P, which is pointing at the end of the array. The length of this array is 1, 2, 3, 4, 5, 6, right? But we want to start from this one, and the index start from 0, so this is going to be 5. So I'm going to say m plus 1 minus 1. I'll go all the way to minus 1 because it's exclusive, and I will deduct 1. So we iterate from the end of each array. Then I'm going to check, first of all, if the pointer that I have here is pointing at like a minus. And if it is minus, it means that we are finished with nums2. So I'm going to say if pointer 2 is smaller than 0, then I'm going to break this loop. Otherwise, I'm going to check if the pointer 1 is bigger than or equal to bigger than 0, equal 0. And also the value that I have in nums1, the value that I have in nums1, which is p1, if it is bigger than the value that I have at nums2 at p2. And if it is, I'm going to go to nums1, because we are going to replace these 3 zeros, right? I'm going to nums1 at where the p pointer is pointing at, and I'm going to put that value in here, p1, right? And I'm going to deduct 1 from p1. Else, which means the value that I have at p2 is bigger than p1. So I'm going to put in p nums2 p2, and I'm going to deduct 1 from p2. Let's go through an example and see how it works. So we start from this point for P1, this point for P2, and this point for P. So we start like the first condition is if P2 is if it is smaller than 0. Is it smaller than 0? No, P2 is 2 right now. So then we check if P1 is bigger than or equal to 0. So it is bigger than 0, and then we check the value that we have here, P1 is 3. Is 3 bigger than 6? No, it is not. So what I'm going to do, it says go to nums1 at where P is pointing at, which is here, and put the value that the pointer 2 is pointing at. So I'm going to put 6 here. Then what I'm going to do, I'm going to deduct 1 from P2, and I'll go through the for loop. So this is going to point at this index now. Then I'll check again if P2 is smaller than 0. No, it is not. So I'll check if P1 is bigger than 0. It is. And is the value that I have here 3 bigger than 5? No, it is not. What I'm going to do, I'm going to nums1 at where P is pointing at and put this value in here. So I'm going to put 5 here. And I deduct 1 from P2. And I'll go through the for loop, and P is pointing at this index now. So I check P2 if it is smaller than 0. No, it is not. If this P1 is bigger than 0, yes. Is 3 bigger than 2? Yes, it is. What should I do? It says go to nums1 at where P is pointing at and put the value that we have at nums1 P1 in it. So I'm going to put this 3 here, and I am going to deduct this from here. And I'm going to deduct this from here. And what is going to happen? P is going to move 1 step back. And we check P2. If it is smaller than 0, it is not. If P1 is bigger than 0, yes, it is. Is 2 bigger than 2? No, it is not. What should we do? We should go to P1, to nums1 at where P is pointing at here, and put the value that we have here in here. So I'm going to put 2 here, and I'm going to deduct 1 from this, right? So which is going to be out of the range of the nums. So I go 1 step forward up, and now I check if P2 is smaller than 0. yes, it is smaller than 0, then we are done. So we don't need to return anything because the question asks us to not to return anything, but you can see that it works perfectly fine. Let me run the code. So the time complexity for these is linear because for the worst case we have to iterate over the both arrays, and the space complexity is constant because we are not using any extra space and we are doing it in place. Thank you.